Okay, now I'll explain the basic concept of limit. So a function, this is what we are talking is limit of a function. We need to understand what do we mean by it. So generally, I give a very simple example. Take a simple example. Let's say a function is defined as say x plus 3. Now, as as x approaches say 2, as x approaches 2, what how will the value of the function get affected? So we write this as x tending to 2. Now look at this graph. We will plot this graph and then I'll write y equal to x plus 3. We want that x tending to 2. Okay, good. All right. So here is this value x tending to 2. Function is approaching 5. Now tending to 2 means the function approaches as x tends to 2 means you can approach either from the left or from the right. So look at this table that I draw now. Take this value of x and this value of f of x. Now x approaches 2 means x is 1.9, then 1.99, then 1.991. All right, 1.999 and so on. It is not equal to 2, but it is going close to 2. What will be f of x? 4.9, 4.99, 4.991, 4.999. Understand? So when x value is approaching, we call this as x is tending to 2 minus, means x is approaching the value 2 from the values lesser than 2. X is approaching the value 2 from values lesser than 2. That is, we call it as x tends to 2 minus, x tends to 2 from the left. All right. So as x tends to 2 from the left, f of x is tending to 5. And in this case, it is tending to values from values lesser than 5, but it can be anything. Values lesser or greater, doesn't matter. Now look at this table. Now x tends to, x is 2.1, then 2. Say 0.9, 2.05, 2.01, 2.005, 2.001. What is it happening? It is x is approaching values closer to 2, but from the right of 2, from this side. See in the graph, this is the graph from 2. This is from the left, this is from the right. What will be the values of f of x? F of x will be 5.1 x plus 3, right? So 5.09, 5.05, 5.01, 5.005, 5.001. So what is happening? As x is approaching the value 2 from the right, all right, we say that x is tending to, x tends to 2 from the right. Then f of x is tending to 5 plus. Okay, x tends to 2 from the right, f of x tends to 5. So both, when you are tending from the left and from the right, it is approaching the same value. Then we say that as x tends to 2, f of x tends to 5, because from left and right both f of x is approaching 5 only, there is no difference. Thus we say we denote limit of x tending to 2, f of x is equal to 5. We denote like this: limit of x, limit of the function as x tends to 2 is equal to 5. What does this mean? Are you all able to hear clearly without disturbance?
Yes, sir.
Okay. So although it is like very important to note, function value is not equal to 5. Many times students confuse that function value is 5. No, it is a way of expression. As x approaches to, function value approaches 5, function value will never be equal to 5 unless function is a constant function. Okay, now this can be categorized into 2. We call this as left hand limit and right hand limit. Left hand limit is limit x tends to 2 minus f of x. In this case it is equal to 5 only. You don't put plus or minus on the limit reached. Only we want how are we approaching, either from the left of x equal to 2 or right of x equal to 2. What value is the function attaining? We don't so much worry about whether it is lesser than 5 or greater than 5. When you say right hand limit, x tends to 2 plus, x is tending to 2 from the right, which is equal to 5. All right. Now we say if this left hand limit, we call it as LHL, and right hand limit we call it as RHL. So if LHL is equal to RHL, then we say that limit of the function f of x at x equal to a exists and is denoted as limit x tends to a f of x equal to L, whatever the value is. So when left hand limit is equal to right hand limit, limit exists, just like the previous example that we took. Sometimes the limit may not exist. Sometimes the limit may not exist. Like for example, if you take signum function, we will just study another example. Consider f of x as signum of x, that is modulus of x by x for all x not equal to 0 and equal to 0 for x equal to 0. Find examine limit of f at x equal to 0. So now when x is positive, so we can do this more easily like this. When x is positive, we can split further. Modulus of x by x, modulus of x will become x. So x by x is 1. So when x is greater than 0, it's equal to 0 when x is equal to 0, and it is minus 1 when x is less than 0. Okay, this is f of x. Now look at the graph. X and y. So here is 0 origin, here this is 1, this is minus 1 on the y-axis. Now when you plot the graph, let's say by this line, orange line, when x is greater than 0, it is 1. When x is 0, it is 0, and when x is negative, it is minus 1. Now let us examine the limit. Limit x tends to 0 minus f of x. This is what left hand limit at 0. All right, left hand limit at 0. Limit x tends to 0 minus f of x. So just before 0, the function value takes the value minus 1. All right, so the left hand limit is minus 1. The right hand limit at x equal to 0 is limit x tending to 0 plus f of x. What will this be? Just to the right of 0, the function value is plus 1. So here you get left hand limit is not equal to right hand limit, okay, at x as x approaches 0. Therefore limit as x tends to 0 does not exist or is not defined. Okay, I'm giving you a very fundamental concept of limit. I am right now not going into the complicated definition of limit. It is just for you to grasp. Now I will give other examples. Yeah, x square minus 1 by, okay, I'll choose slightly a different example. This we have done already. A second. Okay, one more example. Now let us not use mod. Let us use square. Example 3. F of x is equal to x square minus 4 by, or we did x plus 3. All right, we'll do x plus 3. So we'll do x square minus 9 by x minus 3. Okay, what is the domain of definition? Evaluate limit as x approaches 3, or we say, or
x square minus x
uh,
minus 3.
yes, or we say evaluate limit at x equal to 3. It means the same thing. What is the domain of definition? What is the domain of f? Anybody?
Sure.
No, domain has to be real numbers. Now, what is domain of f? What is the domain? Set of all values of x. Huh?
3 minus 3.
No. For domain to be defined, domain for a function to be defined, what are the conditions you put?
Denominator must not be equal to 0.
Expression under the root must be positive, so there is no root here. Only thing is denominator must not be equal to 0. When will denominator be equal to 0? When will when x is equal to 3. So domain of f is x belongs to R minus 3, or x belongs to minus infinity to 3 union 3 to infinity. Okay. All right. So now f of x can be written as x minus 3 into x plus 3 by x minus 3. Now you can cancel this. You can cancel this x minus 3 only since x is not equal to 3. Since x is not equal to 3, you can cancel. If x equal to 3, then this becomes 0. You get a 0 upon a number which is 0. Now this denominator is never 0 because x is not equal to 3. Even if it is 2.99, it is a division by 0.01 or minus 0.01, like that. So it is a finite number. Understood? So we can cancel this factor only since x is not equal to 3. So now it behaves like f of x is equal to x plus 3. Now evaluate.
Equals to 2, sir.
Huh? Now evaluate at 3. Evaluate the limit at 3 now. So now let us see left hand limit. Now it is a straightforward. Now how will the graph of this function be? This will be interesting. But first you tell me what will be the left hand limit.
0, sir.
Why? Why will it be 0?
Sir,
What will be the limit?
3 minus 3 is 0 only, no, sir.
It is not 3 minus 3. It is a number approaching 3. This is not 3 minus. It is 3 raised to a minus sign, which means you are approaching 3 from values lesser than 3. That means 2.9, 2.99, 2.999. I gave these tables to explain you that. It is not a minus sign to show that it is arithmetic plus minus. It is to show that we are approaching from the left or from the right. Now tell me, what is the value? 6. 6. So you are approaching 3. You are approaching 3. X is approaching the value 3. Now when you do limit of f of x, as x tends to 3 plus. What is the value again? 3 plus 3.
Left hand limit equals to right hand limit. It's a
Yes.
function.
Now look at the interesting thing. How do you draw the graph of this function? We'll draw the graph of the function at x equal to 3. 6, 1, 2. So I'll be drawing the line. Now beyond 3, I will again continue the line. Okay, I'll draw it again. Okay, now you see here, very closely you observe here, there is a gap at x equal to 3. 1, 2, 3, 4, 5, 6. This is a straight line, but there is a gap here. At 3, there is a gap in the line. Why? Because function is not defined for x equal to 3. Understand? Now, however, you see a very important thing. Now left hand limit is equal to right hand limit here. Left hand limit is equal to right hand limit. So therefore the limit at x equal to 3 exists and it is equal to 6. Very interesting. Function is not defined. So limit exists at x equal to 3 even if the function is not defined at 3. Okay, what does this mean now? So for limit to be defined, it is not necessary that the function exists at that point. Why? The very concept of limit is we are approaching that point. We are not, it is not equal to the point, the value at that point. So here we are approaching 3 from the left, but we are not equal to 3. We are not taking the values of x equal to 3. We are approaching from the right. We are approaching 3, but we are not taking the value equal to 3. So even though at 3 function is not defined, limit can exist. Limit can exist. So this observation is the very important observation in limits. In understanding of limits, this is very important. Okay, this is a fundamental concept. Now I'll move to another concept of neighborhood of a point. So because based on neighborhood of a point, we'll have to define another more sophisticated or more mathematically intensive definition of limits. So absolute value function, we know modulus function is x, 0 and minus x. For x greater than 0, equal to 0 and x less than 0. Now absolute value of x, as I explained to you, tells you about the distance of the point from origin. Absolute value of x. Absolute value of x minus a tells about distance of the point from the distance of x from the point A. That I'll just explain now. So here you see, suppose we take mod 2 and mod minus 2. Both are equal to 2. So it refers to 2 points. Minus 2 and 2 both have modulus equal to 2. That means the distance mod function means it's a distance of the point from the origin here. Mod x means. Now let us look at this. Mod of x minus a equal to delta. Mod of x minus a equal to delta. This delta, a small quantity, means if within the modulus expression is positive, x minus a greater than 0 will imply x greater than a. Then what happens? Modulus of x minus a, for x greater than a, modulus of x minus a becomes x minus a, and this we can write as x equal to a plus delta. And then when x is less than a, modulus of x minus a will be written as mod of minus of x minus a. Now you take this to the other side, you become a minus delta. X is equal to a minus delta. So what does this represent? Modulus of x minus a equal to delta. This expression, what does it represent? It represents 2 points, x equal to a plus delta and a minus delta. That is a plus delta, a minus delta. which are at a distance of delta from A. So mod of x minus A equal to delta means it gives you 2 points which are at a distance of delta from A. Okay, so concept of modulus you must understand so that you understand what is how we define limits. Now next, modulus of x minus A less than delta. Modulus of x minus A less than delta. This means now two categories. When x is greater than A, it will be x minus A less than delta, which means x is less than A plus delta. Second category, if this is negative, second case, when x minus A is negative, then modulus becomes minus of the negative number. So minus of x minus A. So multiply the minus sign throughout. So x minus A greater than minus delta. X, once you multiply with a negative sign, inequality reverses. So now x will be greater than A minus delta. Okay. So x lies, so you get two conditions. X is less than A plus delta and x is greater than A minus delta. So A plus delta is a point to the right of A minus delta is a point to the left of A. X is greater than A minus delta and x is less than A plus delta. That means all this shaded portion is what the values of x takes. If it was equal to, it takes two values. If it is less than, then it takes an interval. So modulus of x minus A less than delta means the distance of x with respect to A is less than delta. So all these points from A minus delta to A plus delta satisfy this inequality. So this is called as, this x minus A less than delta is called as the neighborhood of A. As you know, delta is small, or we call this as the delta neighborhood of A. This region is called as the delta neighborhood of A. That means it is set of all values from A minus delta to A plus delta. Now, if you do greater than, that means distance of x from A is greater than delta. That means it refers to all the values of x outside of this interval, A minus delta to A plus delta. So this A minus delta to A plus delta is called as the neighborhood of A. This is the neighborhood of A. Next, I will not take, of course, modulus does not take negative values, but also it can take the value 0. That means when x equal to A, it takes the value 0. Now I put a condition that modulus of x minus A is greater than 0 and less than delta. It is greater than 0 and less than delta. So what happens? Everything else remains the same like the previous. You do x greater than A, then replace x minus A by x minus A only, modulus of x minus A by x minus A. Then you add A, you get x lies between A to A plus delta. And when x is less than A, modulus of x minus A becomes minus of x minus A. You multiply with a negative sign and then rearrange the inequality and then add A, you will get x lies between A minus delta to A. So difference between the previous case and this case is x cannot take the value A. X cannot take the value A in this case. If x takes the value A, it will become equal to 0. So look at this. It is the neighborhood of A excluding A. excluding a. So this expression 0 less than mod of x minus a less than delta is called as the deleted delta neighborhood of a. It is called as deleted delta neighborhood of a. Okay, now I don't know whether in your schools this definition of limit was taught. Just a second. So this is called as the epsilon delta definition of limit. And what it says is simple. Once you understand this language, it is very simple. Without understanding the language, we'll keep scratching the head. What is this? Why are we? What does all this thing mean? So I'm explaining it again. Now, if you have understood the concept of modulus, how modulus represents a neighborhood. Now, let f be a function defined in the deleted neighborhood of a. Very important. Deleted neighborhood of a. So at a, it may or may not be defined. And let L be a real number. Okay. For every positive epsilon, however small, there exists a positive number delta such that modulus of f of x minus L is less than epsilon for all x such that 0 less than modulus of x minus a less than delta. What does this mean? What does this mean? No matter, suppose I approach, see, this is what modulus of f of x minus L less than epsilon. See this? This represents the neighborhood of L. Function lies in the neighborhood of L. Epsilon neighborhood of L. Function lies between, based on the previous previous page step. Okay, f of x minus L modulus less than epsilon means f of x lies between L minus epsilon and L plus epsilon. Okay, so f of x lies in the neighborhood of L. For what? For x lying in the deleted delta neighborhood of A. So just look at this problem now. What this question says is, what the statement is now very simple. Now we'll read the statement differently now. Let f be a function defined in the deleted neighborhood of A and L be the real number. If for every positive epsilon, however small, there exists a positive delta such that function lies in the neighborhood of L, epsilon neighborhood of L, for all x which lie in the deleted neighborhood of A. Then we say function tends to L as x tends to A. All right. Now why? And you know the limit exists, and the limit, the limit value is limit f of x as x tends to A is equal to L. This is what it is. So why such a complicated definition? You can see something straightforward now. Suppose the function is y equal to x plus 1. Now as x approaches 1, that means x is in the neighborhood of 1. Function will be in the neighborhood of 2. Function value can be greater than 2 or less than 2, but here in this case it is less than 2. So function will be in the neighborhood of 2. As another way of saying is, as I approach, as my neighborhood values in 1 is become smaller and smaller, then the function value comes within the neighborhood of 2. Okay, so another way to say it is, as x tends to 1, function value approaches 2. All right. Now, why such a complicated definition? Because sometimes if you study a graph like this, I'll just show you a graph of sine 1 upon x. This is a oscillatory function. Okay, you will appreciate the definition of limit when you understand this function sine 1 upon x. Now, sine value of any number lies between -1 and 1. But as x is approaching 0, the radian values inside are approaching infinity, and that too very, very fast. Very, very fast. So what happens is, as x tends to 0, that is, say x tends to x equal to 0.1, then 1 by x will be 10. When x equal to 0.001, then 1 by x will be 100. When x is 0.001, 1 by x is 1000. From 10 to 100 to 1000, it is jumping. X is increasing very small, but 1 by x is crossing a range of values. So you can see as x approaches, the function sine x oscillates between -1 and 1. And it is impossible. You keep going closer and closer and closer and closer, it will keep oscillating. This is the oscillatory discontinuity. So now we will understand the concept of limit now. Now, as I'm going closer, that means as I make my what you call neighborhood smaller and smaller around 0, what happens to my function value? Is it focusing on neighborhood of some number? No, it is oscillating. It is oscillating between -1 and 1. It is not converging to one fixed number. It is just oscillating widely. It is not converging to one fixed number. So although x is in the deleted neighborhood of 0, function value doesn't go to a neighborhood of any number. It keeps vacillating. Therefore, limit does not exist. For this particular function, limit does not exist. Sine 1 by x. Okay. So that is why in such complicated functions, this definition of limit holds very good, because it is very difficult to say as x tends from the left, function value, where is it going? It is oscillating between -1 and 1. So this much only you need to know about the epsilon delta definition of limit. Tomorrow's class, I have to stop early. You can see that I'm still at my workplace. I'm not started for home. Actually, there is a lot of pressure at work. So that's why I was getting delayed every day. So I thought today I'll take class from here itself. So I'll stop the class now. Tomorrow's class, I'll be at home. Tomorrow is 26th. I'll be at home. I may take a little earlier session also. I'll communicate to you.
So can you confirm when will the earlier session be?
Maybe 6. Or
you mean
if you
6 in the evening?
Yes, yes. Not
No
during
morning
daytime.
class, no sir?
No morning class.
Okay, okay sir. Thank you sir.
It may be 6 or same time 6:30. I'm not decided. I'll have to see my morning schedule tomorrow. Okay. So tomorrow we'll continue further. I hope today's class, it was a new concept. I hope you grasp the concept. If you have any doubts, I can take 1 or 2 questions. No doubts? Vishnu Sri, Astuti, Zia, Harshita, Kedar, Pradyumna, Venkatesh. This is a fundamental concept of limit which you need to grasp, although directly you're not using this in your problems, but inherently this is the concept. When you approach differentiability and application of derivatives, that is when this fundamental understanding plays a very important role. Okay, no questions? Okay, then we'll stop. I'm closing the recording. See, due to my schedules will be like this till